Imagine this. You're sitting on a peaceful beach, basking in the sun and enjoying the soothing waves, when suddenly, everything goes haywire. You, the chair, and everything around you are hurled across the planet at a staggering 1,000 miles per hour. It sounds like a nightmare, but this is what would happen if the Earth suddenly stopped spinning. The chaos would be unimaginable, but this is just the beginning. Things would get even worse. We often take Earth's stability for granted, from our 24-hour days to our comfortable climates. The planet has been spinning for over 4.5 billion years, undisturbed by the vacuum of space. But what if, one day, it just stopped? Chaos would erupt immediately, setting off a chain reaction of disasters over the coming minutes, hours, and days. Imagine yourself lounging on a beach near the equator when, without warning, the world halts. Instantly, you, your beach chair, and all the surrounding sand would continue moving at 1,000 miles per hour. If you miraculously avoid being thrown across the planet, you'd still need to dodge flying cars, startled animals, and anything else not firmly secured to the ground. Gravity would keep you grounded, but everything would hurtle eastward until friction eventually slowed it all down. At the North or South Pole, you wouldn't notice the Earth's sudden stop at first because you have no angular momentum there. Imagine spinning a basketball on your finger. The top of your finger at the pole stays still, while any other point on the surface moves with the spin. The same applies to people at the poles of the Earth. Now, picture you and everything else that went flying across the planet finally coming to a halt. Debris is everywhere, and somehow, miraculously, you're alive. Sadly, the worst is yet to come. Even if the Earth stopped spinning, the atmosphere would keep moving, causing a massive global windstorm. These winds would roar at 1,000 miles per hour, and you'd have to move pretty far north or south for the winds to slow to non-lethal levels. Most structures, whether man-made or natural, can't withstand winds over a few hundred miles per hour. The strongest gust ever recorded on Earth was just over 250 miles per hour, while the most powerful hurricane-force winds top out at around 150 miles per hour. Multiply that destruction tenfold, and you start to understand how dire the situation would be. The winds would not only be incredibly fast, but also do something unusual over time. Once the powerful winds finally settled, the world would face a new kind of chaos. Weather patterns would drastically change, and the oceans, along with all the water on Earth, would surge to new locations. With the planet no longer spinning, water, like everything else, would continue to move, causing massive tsunamis and colossal waves to sweep across every continent. For a brief time, Earth would become a water world. Imagine a scene more intense than the tale of Prophet Noah's Ark. Not even a massive ship carrying 2 of every animal could withstand the towering waves, which could reach hundreds of feet high. Yet these giant waves would only be the beginning of Earth's turmoil. Beneath the surface, tectonic plates resting on the Earth's mantle would continue their slow journey over molten rock. Normally, these movements create mountains and valleys. But if the plates continued moving at their usual speed after Earth stopped spinning, the results would be catastrophic. Tectonic plates would collide with unprecedented force, triggering massive earthquakes and volcanic eruptions on a scale never seen before. As the plates crashed into each other, huge tremors would ripple across the landscape, tearing apart the Earth's crust. Denser oceanic plates would be forced under lighter continental plates, causing massive volcanic eruptions that would spew molten lava, covering the atmosphere with smoke and dust. The resulting scars and craters in the Earth's landscape would resemble a scene straight out of a fiery nightmare, like Dante's Inferno. Hours after Earth stopped spinning, the waves calmed, the winds subsided, and the planet reached a temporary state of balance. But this eerie calm was just the prelude to the really strange events that were about to unfold. Nearly all living creatures had been wiped out except for a few species at the poles, like resilient penguins and brave scientists stationed in the Arctic. Sadly, not all of these survivors would last long. The sudden halt shifted every weather pattern, pushing winds from the equator toward the poles. Rainforests dried up while deserts flooded. Surprisingly, some of the best places to be were in the once frozen tundras of Canada and Siberia, where the harsh cold eased, making these areas more temperate. However, this temporary haven would soon face a new problem. The spinning of Earth on its axis creates the cycle of day and night. If the spinning stopped, there would still be day and night, but it would take much longer to transition between the two. Although Earth's rotation halted, its orbit around the Sun continued, so one day would last an entire year, with each location experiencing 6 months of daylight and 6 months of darkness. Under these extreme conditions, things would get rough. The most noticeable change would be the temperature fluctuations. With 6 months of constant sunlight, temperatures would gradually climb. In the beginning, the non-stop sunlight might just make it hard to sleep. However, as the days passed and the area never cooled down, temperatures would soar, reaching over 212 degrees Fahrenheit or 100 degrees Celsius on the sunny side of Earth. This heat would be enough to boil water and melt anything on the surface, turning the daytime side into a scorched wasteland. On the opposite side, where it would be night for 6 months, temperatures would plummet. In the perpetual darkness, the night sky would remain unchanged, with stars and celestial bodies frozen in place, unlike the usual motion we're used to seeing. The exception would be the 7 wandering celestial objects, the planets. While the outer planets might not cross your sky during your lifetime, you'd still likely see Mercury, Venus, and Mars, providing a bit of variety in an otherwise monotonous year-long night. Surprisingly, there might be ways for life to adapt to an Earth with days lasting a whole year. On both the sunny and dark sides of the planet, resilient microbes might survive, even if most plants and animals died off in massive numbers when Earth stopped spinning. Interestingly, some organisms already thrive in places where there's 6 months of darkness, followed by 6 months of constant sunlight. For example, in the South Pole, penguins endure these conditions every year. If Earth stopped spinning, their icy habitat would probably end up underwater. But theoretically, penguins might still be among the best-suited animals to survive. In the deep ocean, creatures near hydrothermal vents called extremophiles could also survive. These unique organisms don't rely on sunlight. Instead, they produce their own food through chemosynthesis, using the heat and minerals released from the Earth's interior. However, if the Earth's core and tectonic plates stopped moving, these ecosystems would collapse too. As for humans, there might be a chance of survival, but we'd have to become nomadic again. During Earth's orbit around the Sun, there would always be a twilight zone where the sun is just rising or setting. These areas would have moderate temperatures. In this scenario, survivors might make their way to the equatorial supercontinent and use it as a base. If they could form a nomadic tribe, they could follow the twilight zone around the planet each year. They'd need to figure out how to grow plants in low light and find drinkable water, but if they managed this, they could avoid the extreme temperatures. Of course, many challenges would need to be addressed for such a twilight community to succeed. But it's fascinating that going back to our nomadic roots might be the key to saving humanity if the Earth stopped spinning. The challenges we'd face if Earth stopped spinning seem almost insurmountable. All life on our planet has evolved to thrive with a day lasting around 24 hours. This timing is crucial and deeply ingrained in our biology. If Earth stopped spinning our circadian rhythms, the internal clocks that regulate our bodies would be thrown into chaos. These rhythms guide our physical, mental, and chemical cycles every 24 hours. When they're disrupted, it can lead to depression, hormone imbalances, and even changes in body temperature. And this isn't just a human issue. Many living things rely on these rhythms to regulate their biological functions. Life evolved over hundreds of millions of years to adapt to a 24-hour day. Adjusting to a year-long day would be incredibly challenging. Now, if only the surface of the Earth stopped spinning, we'd face the problems already described. But if the entire planet, including the core, became stationary, things would get even worse. The Earth's core, made of molten iron and nickel, generates a magnetic field that shields our atmosphere from harmful solar radiation and storms. If the core stopped spinning, this magnetic field would vanish. Initially, there wouldn't be immediate catastrophes, but over time the planet would bake from the sun's radiation. Living creatures would suffer radiation burns, and their DNA would mutate. This would continue until a solar flare or coronal mass ejection hit us, annihilating everything on the planet's surface without our magnetic field for protection. This leads to a big question. Could the Earth really stop spinning? The answer is yes. There are two ways this could happen. The first is if the motion stopped suddenly, and the second is if it gradually slowed down over time. An abrupt stop would be far more devastating, while a gradual slowdown is more likely, as our planet's spin is already decelerating. If Earth were hit by a planet-sized object, the rotation could stop entirely. In that case, the collision would vaporize everything on the surface, making all the other catastrophic scenarios seem trivial by comparison. Surprisingly, a planet in our solar system has experienced just such an impact. Uranus doesn't spin like the other planets. It spins at a 90-degree angle to its orbit. Scientists believe this happened because an Earth-sized object hit it in the past. So it's possible that Earth could be struck by something that disrupts its spin. There's another planet with a peculiar rotation, our neighbor Venus. Venus is similar to Earth in size and is within our solar system's habitable zone. But due to a runaway greenhouse effect, Venus is more like a furnace. What's unusual about Venus is that it rotates in the opposite direction to all the other planets. On Venus, the sun rises in the west and sets in the east. Scientists think this could have been caused by an impact or by the gravitational pull of the sun slowing down its spin and eventually reversing it. While this wouldn't happen to Earth since we're further from the sun, another force could cause this to occur. Perhaps if our solar system passed near a black hole at the right angle, the gravitational pull could stop Earth's spin. However, a more likely scenario is that the black hole would either consume our solar system or throw it into chaos. Right now, the Earth is spinning more slowly than it was a year ago. The planet's rotation decreases by about 1.4 milliseconds every 100 years. While this small change doesn't affect us directly, in the distant future it could become a significant issue. The reason for this slowdown isn't mysterious. It's caused by the moon's gravity. You can see the moon's influence at work if you watch the tides near large bodies of water. The moon pulls on the Earth, creating the tides, which are essential for many marine creatures. However, this tugging slows the Earth's spin slightly with each pull. Interestingly, Earth had the same effect on the moon, eventually causing it to become tidally locked. That's why we only see one side of the moon. The moon is smaller than Earth, so its gravity wasn't strong enough to lock our planet in place. If it had, our days would last a year, and our world would look very different. To understand this better, let's go back in time. 400 million years ago, Earth spun faster, resulting in shorter days, about 21.9 hours long, meaning there were 400 days in a year. Imagine how pressed for time people would have been back then. Looking ahead, we know that today a day is roughly 23 hours and 56 minutes, not exactly 24 hours. That's why we add an extra day every 4 years to keep our calendar aligned. If the Earth continues to slow down at this rate, in 140 million years a day will be 25 hours long. Of course, we won't be around to see this, but if the Earth kept slowing down, it could eventually stop spinning altogether. At that point, one day would last a full year, 8,760 hours long. However, the Earth will face its end long before it stops spinning. But don't worry, it's not about doomsday or human-caused disasters. Instead, the end will come when our sun evolves into a red giant and engulfs the Earth. This dramatic event will occur in about 5 billion years, when the sun uses up all the hydrogen at its core and begins pulling hydrogen from its outer layers. At that point, the sun will start expanding. There is a slight chance the sun won't swell all the way to Earth's orbit. However, even if our planet isn't swallowed up, it will be so close to the red giant that the heat and radiation would overwhelm our magnetic shield, causing the Earth to burn. In this scenario, the Earth would be tidally locked with the sun, ceasing to spin. If you found this journey fascinating, please share this video and spread the curiosity. Let's keep exploring the unknown together.